Hello, hello, hello. We are back once again. Okay, time to have some fun here. I've been thinking of something, and I wanted to do this with you guys for a while here, but we only have a couple problems here. I'm going to challenge you right now to get out a piece of paper, and I want to see if you can beat me as I clunkily write away on my tablet here. And I want to create the table. I want to see if you can beat me. All right, at this point, you should be close. It should take you under 2 minutes. And I won't do the circles this time, but let's just do the chart. Okay. Are you ready? And if not, go get a piece of paper and see if you can, we'll even cheat a little bit. Go ahead and get your grid up. We'll work on the rest of these problems in a second. I'll do my grid too. Okay, you ready? Okay, so if you're doing this and you're following along and you want to take my challenge, or get a piece of paper and just create the chart as fast as you can. Are you ready? And I'm not trying to show off. I just need you to know it this well. So if you're not as fast as this, and I'm going to try to slow myself down here a little bit, um, you need to be able to beat me. So you can always come back. Okay, ready? Sine, cosine, and tangent for the first, all the degrees and all the radians in the first quadrant of the circle. Ready? Go. Cosine and tangent. For 0, 30. You have to have all your degrees in. If we were in class, I'd be doing this with you too. So you need to do it so you don't need to think. And the only mistake you make is talking or getting distracted or some form like that. And I'm just using our rules forward and backwards, right? That quick. All right, so we've created our chart. If you're just catching up, go ahead, pause the video so I can start talking about something else here. But you should be that quick. Might have taken 30, 45 seconds there. So get good at that because you're going to use it and need that for the test and for calculus as you go forward. So that's something you need to memorize forever. Okay? All right, fun time's over. Let's get back to these examples or puzzles. And I actually like these okay too. We've done a ton so far. Okay? And most importantly, and I'm going to rip this off right off the beginning, showed you a couple other iterations of the all-star formulas here that we just used when we manipulated sine plus cosine, sine squared plus cosine squared equals 1. Now take a look down here in the next problem. I'm going to say verify this identity and equals. Make sure that the left side equals 1 or that 1 equals this side. And hopefully by now you're kind of getting the gist and believing in the fact that, hey, let's mess with the side that you can mess with because expanding from 1 just blindly, it's just, there's too many things that it could be. So on the left side, and then this time I'm going to break my own rule. You should be getting good here. Instead of just sines and cosines, let's just use anything that we know of. And 1 minus cosine squared theta, right off the bat, if I'm going to make that whole thing, again, my finish line is when I'm done, I want it to equal 1. So you always have to know where you want to finish, right? And my left side, 1 minus cosine squared, do you remember what that is? Right here. So 1 minus cosine squared, if you're saying, hey, we can write that as sine squared, you would be perfectly correct. So we're going to make that sine squared. Sorry, it's a little sloppy. Let's go ahead and clean that up. That's bugging me. It's not much better. But notice, now I have that term times 1 plus cotangent squared. Now, again, I'll give you all these formulas on a cheat sheet. You don't have to memorize the formulas, but uh-oh, check this out. 1 plus cotangent squared. That equals cosecant squared, doesn't it? So I'm going to use that. Not afraid to use cosecant and cotangent and all this other stuff. Now I have a whole new situation. I have sine squared and cosecant. And the nice thing about that, though, is look at sine squared x. I don't need to do anything with that. But you should be sitting there saying, hey, Mr. J, cosecant squared, and I just wrote that backwards because I'm trying to be goofy as I talk here. Cosecant squared is just 1 over what? Sine squared? And this goes with this, right? And it doesn't go to 0, but it all goes to 1. All done. So 3 steps. We verified the identity. So we've done a bunch of verifications or proofs, so to speak. I call them puzzles. Again, use the hints I gave you along the way and you'll find some success. The reason you need to be so good with all that is we're going to start actually solving trig functions and expressions with algebra and using all these identities. And it could be a little, what do I want to say? A little scary trying to look at some of these things. But, and so here's our problem. And hopefully I'm going to try to make it easy for you. Look at example 8. It says solve the equation on this interval in red here from 0 to 2 pi. It's almost the most important part of the whole problem. And we'll come back to my underlined red there in a minute. But if you want to factor that thing, a lot of times people think this cosine is real scary. And you know, it can be, I understand it. But what if I gave you this and said factor this? Instead of the cosine, I said 2x squared plus x minus 1. All I've done is I've taken the cosines and replaced them with x's. That's it. So if that were my problem, maybe you'd be okay with saying, well, let's see if we can factor that thing. And factoring a lot of people forget anyways. But I think that's like 2x here and an x here. My back terms have to multiply to 1. So the only thing I have to do really, if it were to work, is figure out where to put the minus. And I think you're going to put the minus right there. You can go ahead and check me on that, foil that out in your head for practice. And I'm going to argue that that's the same as this problem here. It's just our problem has cosines in it. So now we're going to start using some of our abilities with algebra to come up with the same thing. Now watch this. Instead of x's, 2 cosine theta minus 1 cosine theta plus 1. This now factored to be that left side, what I just wrote. And I'm going to argue that it's no different than that. It just has cosines in it, so it makes it look scary. So this is the fun part where you actually get to look and write a bunch of stuff that looks all big time and like Will Hunting kind of thing. And it's really just factoring out those things using reverse FOIL. Now remember, using the zero product rule, here's where we have to talk a little bit. You have to finish up and say cosine theta minus 1 equals 0, or cosine theta plus 1 equals 0. On this side, since I'm on the right side, if I subtract 1, cosine theta has to equal negative 1, right? And over here, if I move the 1 over, I have 2 cosine, oh, running out of room, darn it. Oh, the things that makes you laugh. 2 cosine makes me laugh equals 1, and cosine theta has to equal 1/2. So now, if you remember from chapter 6, we now know how to take inverses. So in other words, this question is what angle is going to give me 1/2 and what angle is going to give me negative 1? Well, on a unit circle, if I draw that up here, remember cosine is negative 1 all the way over here at pi for a rotation of pi. That's my first answer, and if I want to write it, let's take this first one, I'll write it right here. Inverse cosine is going to equal pi radians. And we could cheat if we didn't know it. The reason I had you guys just do that chart, well, it's not even up there actually. I'm cheating and using that first side, or just using my knowledge of the unit circle. But remember, first there's two things to consider. The first one is if I'm going to use an inverse, I have to use this top half of the circle for cosine. So hopefully that's a no-brainer. Hopefully that's okay, because that's my limited range of answers I can get out. And by knowing, sorry, I'm hitting buttons on the computer here, that my value over here is negative 1, and I should have a negative in there, I'm sorry, that pi is my only option. So there's my first answer, all right? But there's something else very concerning here is that when I do the inverse of the other one and say inverse cosine of 1/2 gives me what angle. Remember, the inverse function, I'm taking in the ratio, now I'm looking for the angle. Well, if I go up here and I'm looking for 1/2, you should be okay with me saying cosine of pi over 3 or 60 degrees gives me 1/2. Let's say theta is going to equal pi over 3. Right, there is your other answer. So that's how you really, and notice that's here. Clean this up a little bit. This works for me. And in red here, this is going to be pi over 3 or 60 degrees. And what's that's really saying, if I finish my circle, well, let's use some different colors. Let's use that side in black, this side in green. That's saying that the screen side here is 1/2. You guys okay with that? Now, normally that'd be enough, but because I have this being asked, solve the equations, they don't just want one answer. They want all the answers now. Now notice how I got the first answers. My first answers were restricted, so to speak, by my rotation, my limitation for inverse cosine. Okay, so remember that first. From the top half of the circle, my answers for cosine can only be from 0 to pi. For both scenarios, so we just took care of this one and this one, which are here and here respectively. The other thing I'm trying to say is as you go around, sometimes you have multiple answers. And if they want, or you're being asked to find all the answers from 0 to 2 pi, again, I was trying to say that this is the most important part. If you're being asked to find all the answers between 0 and 2 pi, I have to continue around and check this out. If I'm down here, right way, I have the similar triangle down there with the pi over 3 there. See what I'm talking about? So I actually have another answer there. And I can't, because I can only go from 0 to 2 pi, I can't rotate down this way and say, oh, minus pi over 3. It would get me to the same spot on the circle, but you can't say minus pi over 3 because I have to rotate from 0 to 2 pi. So for any additional repeats of this answer or possibilities from 0 to 2 pi, when you do this, you have to rotate all around. That's not minus pi over 3. But remember, 1 pi, 2 pi, 3, 4, this is going to be a rotation all the way around. And if you're saying 5 pi over 3, you're right. So don't forget that you're going to see some of those for sure on the test. Okay? So, and as I'm writing this stuff, and I should clean this up and write this the right way, this was looking for an angle theta. So my first theta we found was pi, right? My second angle that would satisfy this scenario, so theta 2 is pi over 3. And my third one, so there's actually 3 answers. And the reason this is important is you have to be able to account for the 0 to 2 pi, there are 3 answers. And if you don't say all 3, missing this one is just as bad as missing this one. So if they were each 2 points and you don't even acknowledge that this one is in existence, that's minus 2. And so you'd get 2 points for each of the blue and miss 2 on the back end. That's 70% only, right? So ish. So moral of the story, pay attention to this because it's going to come at you the rest of the semester. All right. Now there's another way to look at that thing. And I'm not trying to overload you, but this is where we're headed. If you don't like the unit circle, I don't know where to draw this, and I'll just draw it down here and I will erase it. If you don't like the unit circle and you like to look at things in a different light, some people choose to just look at the normal cosine graph. Remember, there's marks here and here and here. This is pi over 2, pi. This is pi over 2, and so there's a way to look at it. This question's really asking you, I'm looking here, when is your angle 1/2? And what some people do is some people say, hey, here's my graph on an XY coordinate system. This is 1/2. So when are those two things equal? And that's here and here. My picture's terrible, but what'll end up happening is the distance out this way, and you're going to see videos on this later, is pi over 3, which is why we had that answer that we did here. But the other one is also 2 pi, because this thing's perfectly symmetrical. If it's pi over 3 out this way, then it's going to be pi over 3 this way, or back. So another way to find this answer here would have been to say 2 pi minus pi over 3. Get it? Because the distance down this way is the same as this way. And you'll see more videos on this. I think it's like 7.6 or something. That's common. But algebraically, if I got a common denominator here, 2 pi, what is that? 6 pi over 3? Pi over 3, you'll see that's still 5 pi over 3. So there's a bunch of different ways to get the same answer. You get to kind of pick your own adventure at this point. Later on, this graph will save you that I just showed you. But anyways, that's a little glimpse into the future, and I'm not trying to scare you. For now, right now, make sure you always just give as many answers as you can um, on the interval that they're looking. So in our case here, for example 9, let's go ahead and do a little bit more. In example 9, solve the equation from 0 to 2 pi by factoring this thing. Now, we could factor that. That's a difference of 2 squares already, and I'm okay at factoring, which is why it doesn't bother me all that much. But I'll notice see how I don't even see the cosine, I just see x's. But you could write 2 cosine theta plus 1, 2, I'll do it two different ways, okay? 2 cosine theta minus 1. All right, that's going to be this left side. So the question is, when is that thing equal to 0? And remember, using the zero product rule, see if my headset's still working here. It's going to conk out in a sec, I have a feeling. That you have to do one or the other equal to 0, right? So 2 cosine theta plus 1 equals 0. Or 2 cosine, don't forget your theta, otherwise it's wrong. Keeping up head here. 2 cosine. And if I move the ones over in both cases, uh-oh, the hand is not working. Uh-oh. Actually, guys, it's not my hand, it's the computer. I love when I can blame the computer. Slow down a little bit here, sorry. So 2 cosine theta is equal to -1, or 2 cosine 1. Divide both sides by 2. Oh, same thing, cosine theta. Yeah. Now, that's, again, the point where I need to start using inverses. You could have alternatively, if you wanted to do it another way, check this out. This is almost easier. Move that one over. Divide both sides by 4. And then square root both sides. Cosine theta would have equaled plus or minus 1/2, which is the same answers as we have here. So either way, algebraically, you want to use to solve this thing, that's fine. But at that point, we then again have to use inverse functions to go ahead and find the angle that gives that ratio. Inverse cosine, maybe my pen battery is going dead here. I'm sorry as I'm talking out loud because I'm writing this thing pretty neatly. Me at least. Yeah, I'm having a hard time. Keep trying, so be patient. So inverse cosine of 1/2 equals theta, or inverse cosine be careful, there's a -1/2. Almost lost that, my headset went out again. All these challenges with technology, it's crazy. So those are the two scenarios we have. Now be careful again, what's the interval they want answers on, or you're being asked is to find everything from 0 to 2 pi. Now we can cheat. We already know one of these answers. Do you remember? So from before, check this one out. Inverse cosine of 1/2 my answers were pi over 3 and 5 pi over 3. So I'm just going to go ahead and rip those off. Pi over 3 and 5 pi over 3 because we've already done that one. And if you really want to cheat, what we can do, because now the same question is not when the ratio is 1/2, but when is it negative 1/2, you're going to have that occur in the back half of that circle. Excuse me, let's see if my, yeah, shoot. I'm trying to erase some stuff here. But you were going to have that occur again here and here, right? And that half that was positive when I went this direction is now negative 1/2. Remember, cosine's always x. And I'm going to have those same triangles, but on the back end there. So if pi over 3 gets me here, then this also has to be pi over 3. I don't know if you can even see in there, because now I'm trying to fit everything into one little area. I don't know, I can hear guitar in the background. I don't know if you can hear my wife playing guitar or not. But that also has to be, if I'm going to write it, pi over 3 there. Both those angles have to be pi over 3 just to get me in the other spot so that my answer is negative 1/2 for that blue distance out there. So if that's the case, 1 pi over 3, my other answers are going to be 2 pi over 3. And then 3 pi over 3 lands me here, and 4 pi over 3 will come all the way around. Okay, so those are my other answers, 2 pi over 3 and 4 pi over 3. You just got to remember them. So theta here is going to equal 2 pi over 3 and 4 pi over 3. And again, if you really want to write it the right way, what I would write, I'd write them all individually. I would write theta is, gosh, do it correctly if you're going to label them. And you could do it smallest to biggest if you really want to be super perfect. But you would say theta 1 is equal to, what's the smallest? Pi over 3. Theta 2 is going to equal 2 pi over 3. Theta 3, 4 pi over 3. And theta 4 is equal to 5 pi over 3. So those are the solutions to the equation there from example 9. Now, going forward, as we end the video here, make sure you understand that this question here tests everything, not only from this midterm or that's coming up, but from the previous ones too. Can you factor? Can you use algebra to solve stuff? Can we use inequalities to, not inequalities, but, sorry, identities to help us down along the way? Once you do that and use the zero product rule algebraically, can you and are you familiar with inverses? And then are you familiar enough with the inverses and the answers, all these thetas that you're getting, to use the unit circle to get multiples on the interval that they're looking at? So they get quite complicated going forward here, and that's a glimpse of the next week or two. So practice away. If again, don't worry about it, just try. And if I were you, I don't say this too often, but if we were in class, your homework in class now, I'd ask you guys to work on these lecture questions. So if you want, go do these lecture questions and then log into MATLAB and ask somebody if you got them right or wrong, or come find me and I'll get on Zoom with you myself. Again, Mondays and Tuesdays for me this semester, but you know, if I'm using these videos for another semester, I might be there at a different time. But I'm always going to say, go ahead and email me and I'll just find you and we'll get on. Okay. So take care and good job.